CAQ2Q. Today we're going to be talking about a Hygain Tail-twister rotor. We're going to be looking for weak spots and rebuilding and greasing this rotor, and we're also going to be updating the connector. This is a Hygain Tail-twister rotor. This is one of the biggest rotors that Hygain makes for ham radio use. It has lots of turning power for big arrays. It has 3 sets of bearings versus the 2 sets of bearings. And today we're going to be taking care of the connector that's on the bottom of it, and we'll also be looking at the date code. This model is a 1990 version, and it does a really good job. Now I'm going to show you how to check to see the age of your rotor. On the bottom side of it has a stamp on it. As you can see, this is made in March of 1990. We'll be talking about the trouble spots of this rotor is in this connector. As you can see, these are severely rusted and corroded and not making good connection. This is pretty much a bad connector. We will be replacing this with a CATS controller connector. These are about $29 from CATS controller, and very good upgrade for your rotor. Take these 6 1/2-inch bolts and nuts off to access the internals of this rotor. This top piece will come off, which will expose the wedge brake and the bearings. Now we're going to take the top or the bottom of this rotor off so we can access the internal parts of it. And there's going to be some bearings in this bottom race, probably going to go everywhere. We're not going to worry too much about it because we're going to put all new bearings in it. My lights just flicker. As you can see, this rotor here is in desperate need of servicing. The bearings are rusted severely and in need of a good grease job. We're going to take this bottom race out now. We're just going to put them in our cookie sheet. It doesn't look to appear like this rotor has been serviced since probably 2019, or not 2019, 19. This it doesn't look like this rotor has been serviced since 2019. This might actually be the first time this rotor's ever been apart. As we can see, we've got some rust issues here from where the bearings have set for a while. Main thing you want to look for is make sure all these gears in here look nice and sharp and there's nothing broke, like maybe an antenna has stopped on the wedge brake real heavy and stopped it. This rotor is in need of servicing. It's not too terribly bad. I've seen a lot worse. Now we're going to flip it around so we can look at the wedge brake on the bottom side. This is what stops the, it doesn't stop the rotor. This is what keeps it from turning in a big windstorm. If you have a heavy array, you want to make sure that your rotor has a wedge brake. This here is the wedge brake. We want to make sure that it is nice and sharp and isn't broken, and looks like it's going to do its job sufficiently. The next step is to pull the rotor out of its casing and inspect the rheostat at the top of it and inspect all the gears that turn the rotor. Inside here there's another race of bearings. These ones are in a little bit better shape. They got a little bit of the factory grease left on them. If you ever see this kind of the white grease, this is the factory grease that Hygain puts on it. It is sufficient for what they for the life of the rotor, but I like to put a little bit better of a grease in it. Stuff I use is called Super Lube. We'll go ahead and pull these bearings out just to keep from making a mess. We will be replacing all these bearings with new ones. I buy these bearings on eBay. Don't buy, my opinion, don't buy these rotors from Hygain or these bearings from Hygain. There's nothing special about them. They're just standard 3/8 ball bearings. You can buy thousands of them for $10 or so. Next thing we want to kind of do, check out this ring gear. A lot of times you'll see this ring gear will actually be split on some of the rotors. If you wanted to, you could actually upgrade this rotor ring gear to a cast iron instead of a stamped aluminum. But this ring gear here looks to be in really good shape. None of the teeth are missing. It doesn't seem to be worn or broken. We'll go ahead and clean this up. I just used some WD-40 on it. Clean this old grease off of it. We'll be applying new grease. Just want to get this race nice and clean for the new bearings to go. You can see where the bearings have set for a long time in one spot. Really doesn't hurt it any. I guess if you wanted to, you could actually buy a new housing for it. This one actually has a little bit of been worn pretty good, but it'll still rotate. You could also use brake clean to do this. It wouldn't hurt anything to just use brake clean. Probably evaporate a little bit better. This is severely worn on this one. I might try to file it a little bit. I want to kind of turn these gears. Make sure they all turn pretty good. Okay, this is where the bearings, this rotor has probably been in the air for a long time and in a stationary spot, and I'm talking more like years at the same spot and never turned. It's actually maybe the wind has blown it, and a lot of weight's probably been on this side of the rotor and caused these dimples to appear where all the bearings have set for so long. I want to see about getting a new one of these, or getting maybe I have a used one that's in a little bit better shape. Next thing we'll do is we'll test this rheostat, make sure it's in good shape. Okay, first thing you want to do, we want to turn this rheostat, make sure it's nice and smooth. Also look up underneath this side of this, make sure this isn't worn out. I've actually seen these cut completely in two. And we want to read the entire rheostat. The entire rheostat needs to read 500 ohms. So we're just going to touch it here, and we're going to read it. And we're at about 476, that's close enough. And then the next thing we want to do is just kind of put this on the ground, and one over here to a spot we can find ground. And we're just going to turn this and make sure it kind of goes smoothly. It didn't go smoothly because my fingers come off of it.
Extra hand?
Yeah.
What do you want me to do? Don't move that.
Okay.
And you might say, I'm growing a third hand here. What do you want me to do?
Just turn the rheostat when I tell you.
See, now with my third hand.
And now with my third hand, I'm going to check this out, and I'm going to turn it real smooth and make sure that it reads from 0 to 500 ohms the proper way it should. And that's a good rheostat.
Rolling.
Okay, I marked all these connect these wires because they're kind of hard to see which color is what. I marked them just with dashes 1 through 8 corresponding with the on the bottom of it. I'm going to take these wires off now, unsolder them, and we're going to take this piece off to replace this. The used one. We'll put a used one on here that don't have any marks. It's out of a smaller rotor, but this is the same part number throughout the entire series of the rotors. So at this time, that's what I want to do. I like to use these little hemostats. You can buy them at Hamfest, and to get your connections off there. It's just nice to be able to pull and not burn your fingers. Now we got all the wires off. These two big black ones will go to frame of the case. Now we're going to take this piece off of this so that we can put a new gear on this, or new housing on this, because this is badly worn in here. We'll lift this off here now. Two wires that will stay on will be the ones for the wedge brake. Just like in my other video. Inside here you can check out your springs for your wedge brake. You don't have to do this if you're not taking and replacing this bearing race. You can just kind of look inside here and look at the side. But since we got it apart, we're just going to take a look at it. This is the wedge brake. I guess if you had to go this far to get maybe replace this wedge brake, if you had to. So we're just going to move on to replacing this bearing race. I'm going to replace it with a used one off another rotor. Okay, now we're going to pull this motor assembly off from this race because this race is bad. You're going to need a 5/16 wrench. We're taking these 3 bolts out. And to get to this one, you'll have to have an open end to get in there because your wrench will hit, the box end will hit there. So that's what we're going to do now. Okay, now we're taking the bolts out of the bottom of this. At least 3 that hold the motor on. If you ever had to replace the motor, this is the steps you'd have to take to replace the motor. So this is a Rheostat motor, the whole shooting match to replace this. One good thing about Hygain's rotors, a lot of the parts hasn't changed since like the 50s. Matter of fact, this rotor here was actually just a 4-wire rotor. Part numbers are the same, so it's the same part number. They haven't changed it. I'm not going to worry about these pieces here because this is where the wire's hooked up, and the other side, this is where the wires will be hooking up on the bottom of this one. So now we're just going to mount this motor on this older one since it's not damaged and don't have the grooves for the bearings. You put this back together, make sure you don't forget this little spacer here. It goes on top of these gears in case you might lose it. These little spacers on top here is kind of easy to lose, or washers. Make sure you get them put back on. Okay, so we got the motor and the rheostat bolted onto the new or the old previously used gear set. Now we're going to move on to putting the bottom piece on. Okay, we got them bolted up now. Now we're going to work on putting the connector on the bottom. So this is the connector that's going to replace the one that's bad in the bottom of it, so it won't go bad again. Comes with these comes with 8 of these pins to put inside this, and then one for a connector for the rotor cable. So to get these, I usually solder them on these on the wire itself, and then put it in the connector and pull it through with a piece of or my hemostats. This also comes with mounting hardware in here to mount this onto the rotor. I usually like to start with wire 1, pin number 1 that I took off. The big wires will get grounded to the frame. It says this in the instructions when you buy the instructions for the connector. Very detailed instructions. If you decide to get them, go ahead and read them before you do all this. I've just read them so many times that I got it by heart. I just do this, and then I run some rosin in that little fingernail polish. You'll have to edit that. I put this rosin in a fingernail polish container, which you always have to go like that to get it off. solder everywhere. Make sure you hit this with solder. I try to make sure these are up because you don't want solder to get into this pin part. All I want it on is the wire itself. And I'll just go through and solder all these up, get them all on, and then I'll push them into the pins all after I get them all on there. I like to mark pin number 1. I'm trying to figure out which one it is. Start with pin 1. Pin 1. Pin 2 is the next one. It's the yellow large one. And I've got too much solder right here. I'm going to have to fix that. This is the color code for the internal of the rotor, but after time it seems like the colors will fade. So that's why I kind of mark them with a marker as I'm doing it. You can kind of tell that this one at one point was like a light green, but you know, this is a yellow right next to it. So definitely mark them. Yeah, I usually just put 3 little hash marks, or however many hash marks it needs, and you just keep on going down the line. Putting them in your little connector, and Like I said, I take the hemostats. These are a must. These go to a ham fest or. Okay, this is after the connector has been installed, and then here it is, all the wires inside of here. Just make sure none of these are touching one another as far as electrically. Some of this shielding kind of can set there. But, next thing we got to do on that, and make sure the wedge brake isn't going to hit it. I kind of bring it over here to the side. And, next thing we have to do is we need to bring these up here and solder them in place to this little connector right here. That's the grounds. Okay, so we have went through and we have changed the motor, in case you ever had to change the motor. We have changed this bearing race, in case you ever had to change this bearing race. So now I've showed you that. Next thing I want to go over is the clocking of this rotor. A lot of ham radio operators will veer away from doing their own work because of this, scared of how to clock this rotor back. This is not hard. The first thing you need to do is we need to take this rheostat and we need to turn it completely counterclockwise. We're going to go ahead and put some grease down in the rotor for the ring gear. This also helps hold it in when you put it into the rotor. The next thing we want to do is, if you can see this, if you see this little notch, we want to line that notch up so that it is touching this and kind of right there. Holding this up. Now we're going to do that, and I'm just going to put this ring gear in there like this, slide it over the gears, kind of get it to go down in there. Sometimes you got to fight it a little bit, it'll go. I made a mistake. Don't ever do this. You see how that center of that ring gear slid in between this? Your rotor won't work, so we need to pull this back out just a little bit and turn it, or even move this over just a little bit. Okay, now if you can see how this is up close to this, but we still need to move it up so that it actually comes to the contact of this contact, but not too much. So we spin this gear right here. So we're going to spin this gear to whatever way makes it turn that way. So as you can see, I'm going to turn it around here. As you can see it moving, and then we're going to see this play. We want to get it almost so there's no play. Still play there. Okay, there's no play. Just go a little bit more. Okay, now we're good. Just stop. And what that's doing is it's kind of on the opening end of this connection. Now the next thing we're going to do is we're going to put the bearings, the new bearings in the races, and we're going to put them in the bell. We're going to clean this race up really good. Okay, we got it all together now. We're going to put a little contact cleaner on this here rheostat, give it a nice rub down, and clean this connection really well. Nice clean rheostat. Okay, now we're going to line this up. You see this little notch right here? We're going to line this up in here with this. And these are going to line up just perfectly because we clocked it correctly when I showed you how to clock it. This is what all the hams are afraid of. So it just goes in. And it's clocked correctly. Alright, we're going to put the race in here. We're going to put all the bearings in. Okay, we got all the bearings in. I'm just going to put some grease on top of them here, which will eventually travel down to the bottom. And I'll also put it on the race on the other side. If you want to watch my other video, it goes over the grease that I like to use. It's called Super Lube. Next thing we're going to do, we're going to clean this race up and this race on the bottom. Okay, the bottom race, I got all the old bearings out. Just put you some grease on here. Just trying to hold this race in place. And we're going to put all new ball bearings in that. Bottom side. Okay, now we have two sets of races ready to go on. I'll put a little bit of grease on this top part. And I'll put a little bit of grease on the race in here. And at the bottom of the race. And now we're going to put it together. It doesn't matter how it goes. It doesn't matter if it doesn't matter because we did all the clocking down there where it needed to be clocked. Another rotor ready for the air. Okay, next we're going to put this end on. First thing we want to do, we want to put this big heat shrink over top of it. Just slide it down, let it go. Also this little shell, slide it on, let it go. It's kind of nice to have a little vise to stick your stuff in. Don't crimp it down too hard, you know, use common sense. Next thing we're going to do is we're going to put this little connector on. It's just these little connectors right here. Come in the package of the connector for the kit that you'll buy, and you just kind of cinch them on there and take your little needle nose vice grips, crimp them down, and solder them up. Okay, now we got all the connectors on. We need to insert them in here. You just got to make sure whatever color code you put in here, you remember the 1, 2, 3, 4, 5, 6, 7, 8 color code that you put out. So your thick wires in the rotor cable need to be in 1 and 2 on this connector because they're the load carrying ones for the motor. So we're going to do white first, then we're going to go black. So you gotta make sure it gets sensed down. You'll hear it do a little click. One, you got white and black. Then we'll go red. Thing with these, you can't grab a hold of them with your thing there. You got to get like a little screwdriver or pick to push it from the back side. A little baby screwdriver usually helps out pretty good. So I'm just using this little tack to finish seating the small wires, so you don't, because when you push on the back side of the wire, it don't want to go in. So we're going to go red, yellow. That one's seated. Orange. I got too much solder on that one. That's what you got to make sure when you solder these, you don't put too much solder, or they don't want to go in the connector. That's seated, and then we'll go green. Like I said, the color code doesn't matter as long as you remember it, write it down, maybe write it on the back of your rotor. I wired all mine the same, except my red and my thick ones were red and black instead of this one is oh yeah, my thick ones were red and black, and these ones were white and black, so it's just the way we'll have to remember to. We'll have to remember the color code, write the color code down. It's got too much solder on the back side. And it's all seated. If you can see inside there, you see that all of them's kind of really up against it. And you just put your shell on, screw it down, put your little connector here on the back. Right here. Put your screws in. Now take a small screwdriver, cinch that down. Here is the finished product. And it got a nice heat shrink that goes up over the rotors, so that way it keeps the water out, and work for many years. 73s all.